Okay, so in this video we're going to look at decision structures, and sometimes these are called conditional structures or selection structures. It really depends on the resource that you're using. But the big idea is that we can execute some set of instructions selectively based on some particular condition. So also in this video we're going to continue using our turtle module and also a lot of the code that we had developed in drawing a regular polygon. So you'll see that we have our code here from our last video whenever we developed this draw regular polygon procedure. So we still have the creation of our turtle, changing the shape of it, changing the background color to black, and changing the color of our turtle to being yellow. So the only thing that I have changed for the draw regular polygon procedure is the distance that the turtle goes forward. So I changed that from 50 to 10, and that's just so that we don't draw off the screen for some of the things that we're going to do today. So the first thing that we're going to look at is making use of this draw regular polygon procedure to approximate a circle. So if we were to call our draw regular polygon and pass in the value of 20, indicating the number of sides, we can see how close that gets us to approximating a circle. We know the more sides that we have, the closer it should look like a circle. So that looks okay, but I think we can maybe do a little bit better. So I'm going to change this to 30 and see what happens. So let's go ahead and run this again. And that's a pretty decent approximation of a circle, so I think we'll use that. So having 30 sides there. Now, what we can do is modify our draw regular polygon so that as the angle of our turtle changes, notice that each time we go through this for loop, we are in fact changing the angle for our turtle based on how far we turn left. And what we can do is specify maybe a particular color depending on what direction the turtle is facing in. So if he's facing between 0 degrees and 30 degrees, he's using this color. If he's between 30 and 60, he's this color, so on and so forth. So this is where we're going to be making use of our decision structures. So let's move down to the Python interpreter and see what these decision structures look like. So the simplest type of decision structure is what we call the single if. And you use the single if you want to be able to do something under some particular condition being true. You want to print out some statement or execute some statements on some condition being true, but if it's not true, you really don't want to do anything else. So the way we structure that is we say if, and then we would have some particular expression, some boolean expression that we can construct. So we'll say boolean expression, and then a colon, and then whatever we would have below that. Now that's not valid syntax, but what we would put below that is just simply the statement or set of statements we'd want to execute. So let's maybe think of an example. Say that we want to print out some particular phrase based off of whether we recommend a movie. So we'll say that the rating for this movie, so we'll have a variable called rating, is 6. And we'll say that any movies that have a rating greater than or equal to 5, we recommend it. So the way we would write a decision structure for that would just be if, and then we'd specify our variable rating is greater than or equal to 5. And this greater than or equal to is what we call a relational operator. So it's just simply comparing the value that we have in rating to this value 5 here. And then we'll put colon. And then down below that, we'll just put the statement that we want to execute associated with this being true. Now, if it's not true, we won't do anything at all. So we'll just do print and say recommended. So if we hit enter a couple of times there, we can see that based off of the rating of 6, we would recommend that particular movie. It would be recommended. Now, what if we wanted to print something out if, say, the rating was not greater than or equal to 5? Well, we could use what's called an if-else structure. So once again, we could compose this if statement, but then we'd have an else, colon, and then below that we could print out maybe not recommended. So the movie is not recommended. Maybe I should have said thumbs up and thumbs down. So we could have that, and if we hit enter twice, we can see that we still recommend this movie because we haven't changed the variable for rating here from 6. But let's change that. Let's change rating there. And I'm just using the up arrow keys to move through the previous commands that I'd entered in. So we'll say the rating is now maybe 3 for a particular movie. And we'll hit enter again, and then we'll use our up arrow key and see what happens whenever we run it this time. So we can see now that it's not being recommended. So what's happening there is we're testing to see if the rating is greater than or equal to 5, It's turning out that that's false because 3 is not greater than or equal to 5. So it goes down to this else part, and it doesn't do any test there. As soon as it hits this else, it knows that it's going to execute the associated statement or set of statements with this else clause here. Now, it may be the case that what we're wanting to test out doesn't simply fall into two categories. You know, if this is true, we do this, else we do that. So we may have what we call multiple alternatives. And if we have multiple alternatives, we can use what's called an else-if type expression. So we could still say if, and then specify some particular rating. And maybe we want to categorize, if we're talking about a rating system between 0 and 10, we could say if the rating is in fact greater than 8, then we would do one thing. Say we'll print out, it was excellent. That was an excellent movie. So that would be maybe the rating for it. It's not just simply a recommend or not recommend. We will have some scale there. Else if, so we type that EL and then IF. That's the keyword in Python. And then we'd say rating, maybe if it's greater than 5 and the rating is less than or equal to 8. And let me put a space in there. So less than or equal to 8, colon. Then maybe we print out good. So the movie was good in that particular case. And then we'll have another else if. So that's ELIF. That's the abbreviation that they use for the keyword. So if the rating is maybe greater than 3 and the rating is less than or equal to 5, then we'll print out, well, you can see it if you're bored. So maybe we'll say if you're bored is the rating we want to print out there. Now, on these two previous if statements or else if statements that we had, you see that we use this word and. And what that's saying is we have to meet both of these conditions here. So the rating has to be greater than 5 and the rating has to be less than 8 in order for us to print out good. And in this particular case, we had to say the rating's greater than 3 and the rating's less than or equal to 5 in order to print out if you're bored. And then we'll have one last one. So if we've exhausted all possible choices and we're only left with one other choice, there's no reason to really do any type of comparison here. We can just say else. So we can say else here, and we would print out, in this particular case, maybe horrible. So that was a horrible movie. Don't even bother seeing it. So we can see what happens here. If we hit enter a couple more times, you can see that having our rating there, so what do we, I forgot what we put in. So we had a rating of 3. So 3 is not greater than 3. So it's not greater than 8, not greater than 5, and less than 8. It's not greater than 3 and less than or equal to 5. So we print out horrible. So notice that on two of these here, the 3 is in fact less than or equal to 8. But the problem is it didn't qualify on this first part here. So if the rating is not greater than 5, we don't even bother checking this bit over here. Now, if we would have changed this and here to an or statement, then we would have printed out good, and it wouldn't bothered to have tested anything else. So it turns out with the if, else type structure, as soon as it meets one of the conditions, it doesn't bother testing out any of the other conditions. Let me go in and change the value that we had for rating. Let's change it to maybe 7. And then we'll go and run that same exact decision structure again, and we can see this time that we get a rating of good. So it turned out that 7 is greater than 5, and the rating is also less than or equal to 8. Now it turns out the way that we structured this, we could actually get rid of this and rating less than or equal to 8, and rating less than or equal to 5. And the reason why we could get rid of those is because we execute these statements in order. So we first test this, then we test that, and then we test that to see what happens. So we really didn't need to have this upper bound here as long as we had this in a proper order. Now, if we didn't have it in a proper order, then we'd need to be very careful to include upper bounds. So that's really the big 3 things that we would need to know about regarding the syntax. And we can have as many else-if type structures as we like. So if we needed to have more ratings and more scales in here, then we could certainly have more else-if type structures. So let's just do a quick review of the things that we've covered dealing with the decision structures. So I'm going to scroll back up to the very top whenever we first started talking about single if. So we said that the single if was the simplest type of decision structure we could have. So these were cases in which we just wanted to print out or execute some particular statement or set of statements associated with something being true. If it's not true, we don't do anything else. Now, I did mention something before that I really didn't explain, and I talked about this thing here being a boolean expression. And a boolean expression is just an expression that resolves down to a true-false value. So whenever we're comparing this rating to 5, checking to see if it's greater than or equal to 5, we know that that resolves down to either being true or false. Now, if the single if is not sufficient, so say for instance we wanted to be able to output something whenever something was not true, whenever the statement's not true, then we can use what's called the if-else structure. So else is going to be executed if this thing turns out to be not true, so it being false. And then we looked at the multiple alternatives, so we ended up needing to be able to express something that has multiple alternatives, not just simply, if this is true, let's do this, otherwise else, let's print out or do something else. Then we could use the else-if structure, and we can have as many else-ifs as we like. So this isn't an exhaustive discussion on decision structures, but hopefully it gives you an idea of what's going on. We can set up certain conditions and selectively execute some set of statements based off of some conditions being true. So let's take this knowledge that we have and go back and write a function that allows us to specify a particular color based off of what angle or what direction, what heading our turtle is currently facing. So back here in the Python editor, what we're going to do now is just write another function. And I'm using the word function since this thing is going to return a meaningful value. I used the word procedure here for draw regular polygon before because it really doesn't return a meaningful value even though it returns the value of none. Again, don't get too bogged down in these types of terminology, but generally functions return a meaningful value. Procedures do not. So we're going to call this particular function get underscore angle underscore color. So we're getting a particular color based off of what angle our turtle is facing. And we could divide our circle up into several different parts. What we're going to do is divide it up into 4 quadrants. And we'll say between 0 and 90, we return one color, 90 and between 90 and 180, another color, 180 and 270, another color, and then finally another color between 270 and 360. So that's the general idea here. So what we'll do is just make use of our decision structure using an if statement. So we'll say if t dot, and I'm going to make use of a built-in function associated with the turtle module called heading. And it's able to return the heading or the angle that our turtle is currently rotated. So if the heading turns out to be greater than or equal to 0 and t dot heading is in fact less than 90, that'll be our first quadrant, then we're going to return this value of red. So that's a color that we can have, that we could pass into this color function. So this return statement hopefully isn't too frightening. What's going on here is that whenever we call this function getAngleColor, it's going to give back, or the term we use is return a value. So if it turns out that our turtle heading, whenever we call this particular function getAngleColor, is 45, then it would return the color red. And now we'll fill out this so that no matter what heading we have between 0 and 360, it will return a particular color. So we'll say that we'll do an else if, and we'll say else if turtle heading. If it turns out to be greater than or equal to 90 and turtle heading, actually I forgot a parentheses here. Let me go back and do an open and close parentheses on this one here. Otherwise we'll have a problem. So we'll do t dot heading, open paren, close paren, and this time we'll say less than 180. So the second condition we have tests to see if our turtle heading is greater than or equal to 90 and less than 180. In that case, we'll return, let's say, blue. So blue is another valid color that we can have. And maybe is to avoid so much typing, I'll do a copy of these 2 lines of code here. Let me pick up the very beginning here. So we'll do a copy of these 2 lines down below. And only thing we need to change here is this value should be now 180, and we'll change this value here to 270, and we'll return the value of, I don't know, yellow in this case. And then finally, we'll have an else statement. So we'll say that we're only having 4 alternatives here, so we've exhausted 3 alternatives. There's no need to do another comparison operation here to set up a boolean expression. Certainly we could have an else if and say if the turtle's heading is greater than or equal to 270 or less than 0, then we'll return green. But we don't need to do that. We could just simply say else return green if that's the only other alternative that we're going to have. And that is it for our get angle color function. So what we're going to do is, as we draw our polygon, we're moving forward and then we're turning left by some angle. And eventually we would keep moving forward and turning left until we move out of one quadrant into another quadrant. And what we're going to do is be able to set our color based off of what quadrant we're currently in. So we'll do T color, open paren, and as opposed to fixing a specific color, we'll just call our get underscore angle color function. So angle underscore color, open paren, close paren. So this is perfectly valid. The only thing that this color function expects to have in terms of parameter is a valid color. And so since this get angle color function returns a color of red, blue, yellow, and green, and those are all valid, then that's a perfectly valid expression that we can have in Python. That is not a problem to have as a parameter, a function call, as long as that function returns a particular value that's valid for this function, a color in this case. So let's go ahead and run this and see what happens. So I think that all the syntax looks okay, so let's go ahead and run this. And we can see that we had red as the first quadrant, blue, and then yellow, and then finally green here. So it's looking pretty good. Another thing that we may want to do is we could put this draw regular polygon inside of a for loop so that each time around the for loop, maybe we move just a little bit, maybe do a turn left or turn right just a little bit. I guess we should do a turn left in this case since we're turning left inside of our draw regular polygon. But let's set up a for loop here. So we'll say for I in range, and we'll say that we'll use the value of 30 here. And let me put this down on a couple other lines and put a colon. And then we'll do a home and tab this over. And so we're going to do this 30 times, and then we'll draw a regular polygon passing in the value of 30. So that 30 there just tells us the number of sides. So that ends up drawing an approximation of a circle for us. And the other thing that we'll do is just do a slight turn left. So every time that after we complete a particular circle, we'll do a turn of left by 12 degrees. So let's go ahead and run this and see what happens. So we draw one circle, and now we're drawing another circle, and you can see that each time after we complete a circle, we are in fact moving 12 degrees to the left. So eventually we will do 30 circles and hopefully have an interesting design whenever we complete it. So let's just go ahead and watch this. I'll probably speed this up whenever I edit this so it doesn't take so long. Okay, so our turtle is finishing up here. You can see him flashing different colors, and finally he has completed all 30 circles, and he was moving left by 12 degrees after he completed each circle. So eventually he winds up back to the original starting point. So pretty cool looking design here, and you can probably imagine doing other designs depending on what sided polygon you wanted to have. It doesn't have to be circles. You could have pentagons, octagons, heptagons, whatever you wanted to have in terms of drawing some interesting designs. But hopefully from this particular video you got a good idea of what's going on with just conditional statements. So we used conditional statements here to change colors based off of what quadrant we were in, and we divided our circle up into 4 quadrants there. So that's pretty much it for this video. If you're interested in learning more about decision structures, I'll probably have some more information in later videos. Certainly do some research online. You can always learn a lot just by doing a Google search and finding information on various websites. So that's it for this video.